Alright guys, welcome to this page of the notes, and I've got a great one for you here as our last problem. I'm really excited about this one because I'm going to refresh your memory on one more thing from Algebra 1 when it comes to writing the equation of a line. And it's this part right here. Standard form. What does it mean to write an equation in standard form? Well, if you go back to page 1 of these notes, we looked at two different ways of writing the equation of a line. There was slope-intercept form, there was point-slope form. I didn't mention this one. Let's talk about it now. Here's the way standard form works. Again, hopefully you remember from Algebra 1, but if you don't, here's what it is. Standard form is this. It's going to be ax plus by is equal to c. Now, a couple of things have to happen here. What is happening here is where a, b, and c are constants. That's just a fancy way of saying a, b, and c, they're just numbers. They're coefficients. Right? They're just going to be numbers. But there's also one last little added detail, and it's this. In standard form, A, this guy right here, it can't be negative, and it can't be a fraction. But just A. B can be negative or a fraction. C could be negative or a fraction. I don't care about B and C. Just A. A can't be a negative number, and it can't be a fraction. So that limits you to positive whole numbers. A must be a positive whole number. A must be a positive whole number. So that's sort of our refresher from Algebra 1. Again, if you're struggling to remember that, don't worry. As we go through the problem, I'll show you exactly how we go ahead and put a line in standard form. Let's keep going with the problem. Here's what I see. I see that I've been given a point. Fantastic. I've been asked to find a line that is perpendicular. That means I need the slope that is the negative reciprocal. Ooh! An extra little twist. Please notice, this line is not in slope-intercept form. I have not solved for y. We're going to have to do that. All right, so I got a few extra little twists in this problem. Really excited about. Love algebra. Here we go. Let's just jump into this. Okay. I need to write a line. So y minus y1 is equal to m times x minus x1. In order to write the equation of a line, I need a point. Fortunately, I was given a point, 3 minus 1. That's my point. But I also need a slope. Now, in order to get the slope, I got to get the slope from this guy, right? It's got to come from here. This is my other line. So I need to know what the slope of this line is, so I can take the negative reciprocal of it. But it's not in slope-intercept form. So let's do that. You've been given negative 3x plus 2y is equal to 4. Well, in order to get this into slope-intercept form, you just got to solve for y. Okay, we can do that. Add 3x to both sides. That means that I have 2y is equal to 3x plus 4. All right, we're almost there. To get the y by itself, divide both sides by 2. That gives me y is equal to 3x plus 4 over 2. Finally, to get it in slope-intercept form, I'm going to do 3x divided by 2 and 4 divided by 2. And you're just about there. Y is equal to 3 halves x plus 4 divided by 2 is 2. Now, guys, remember, this was the line that I was given, which means I needed to find its slope, which I did, but I want a perpendicular line. So, what does the slope of my line, right? This is the slope of the line I was given, right here. Look, right there. That's the line I was given. There's its slope, 3/2. I want a perpendicular line. So I need my slope to be what? Yeah, I need it to be the negative reciprocal. So the negative reciprocal is negative. It's positive, so it would be minus, and flip it, 2/3. Fantastic. All right, guys, here we go. Plug and chug. Right, I know my point, x, y. Plug those guys in for x and y. I know my slope, negative 2/3. Plug that in. I'll do it right over here. So y, careful, watch your signs. Minus a -1, right? Y minus a -1 is equal to my slope, negative 2/3. X minus 3. And here we go. Y minus a -1 is going to be y plus 1. Negative, oh, actually, nope. Distribute. Negative 2/3 x. Negative times a negative is going to be a positive, right? Negative times a negative is a positive. And fraction times a constant. This is the third time we've seen it. Multiply that 3 into the numerator. 3 times 2 is 6. 6 divided by 3 is 2. Okay. Subtract 1 from both sides. Okay, now, here we go. Look. This is slope-intercept slope-intercept form. Now, in order to graph, I want slope-intercept form, right? Because y-intercept, slope, right? Easy to graph. Plot the y-intercept right there. Positive 1. Boom. My slope, negative 2/3. That's down 2, right 3. 1, 2, 1, 2, 3. Do it again. 1, 2, 1, 2. Works so well, do it again. Down 2. All right. I ran out of space going that way. So going down 2 and right 3 is exactly the same as up 2 and left 3. 1, 2, 1, 2, 3. Right there. Works so well. Do it again. 1, 2. And that's working really well. Boom. Awesome. Well, I ran out of space. Connect the dots. Make sure you extend your line all the way through the coordinate plane. Oh, that ain't bad. Put arrows on both ends so that I know you know that line just keeps going all the way to infinity. And right there, you just graph the line. But careful. I asked for you to give me the equation in standard form. So, we've got some work to do. Here we go. This is slope-intercept form. To get the equation in standard form, remember, I'll write it down here again. Let me write it down here again. I need ax plus by is equal to c. So here's what we're going to do. We're going to take this guy, y equals negative 2/3 x plus 1. Look at where the x is in standard form. Please notice the x is on the, there's my equal sign, right? The x is on the same side as the y. Up here, y equals x. The y and the x are on opposite sides. I need to get that x over here. How do I do that? Well, it's a negative 2/3 x. So add 2/3 x to both sides. So let me show you how this works. Y is equal to negative 2/3 x plus 1. I'm going to add 2/3 x. When I do that, I get 2/3 x plus y is equal to 1, right? Because those guys cancel each other out, leaving me with just the 1 over there. Close, close, please look, right? A, x, plus b, right? There's an implied 1 in front of that y, right? So b, y, equals c, right? A, B, and C need to be numbers. Just numbers. 2/3, 1, and 1. Awesome. But there was an added stipulation. If you recall, A must be a positive whole number. Question: is 2/3 a positive whole number? Well, yeah, it's positive, but no, it's not a whole number. So, how do I turn 2/3 into a whole number? Well, again, hopefully you remember from Algebra 1. If you don't, here's how you're going to do it. Whatever the denominator is, multiply everybody by that denominator. So, I'm going to multiply this whole thing by 3. That means I am going to distribute the 3 to everybody. Here's what happens. 2/3 times 3. The 3's cancel each other out. I'm left with 2x. 3 times 1, well, that's 3 plus 3y. 3 times 1 is 3. And this right here is standard form, where this is my A, B, and C in AX plus BY is equal to C. Again, the way, if that leading coefficient, if that A is ever a fraction, how do you turn it into a whole number? Multiply the entire equation by whatever the denominator is. Whatever it is, doesn't matter. I don't care what the number is. Whatever it is, multiply the whole thing by that denominator. They'll cancel each other out, right? And just leave you with the numerator. There it is. That's a positive whole number. We're good. All right, so guys, wow. I had a really, really good time reviewing Algebra 1 with you. Hopefully that's bringing back a lot of good memories for you. If it isn't bringing back good memories, I certainly hope that you have a better understanding at this point of writing equations of lines and graphing them. They are both very, very important skills, not only in Algebra 1, but here in geometry as well, and definitely when you move forward into Algebra 2, being able to graph lines, really, really, really important concept. So spend as much time on this as you need to get good at it. You want to be good at being able to write the equations of a line and graph those lines. Again, I had a great time going through this with you. I'll see you next time.